Okay, let's start. Today's tutorial was about queue. The first question, as you know, the data structure of queue is inverse in compare with a stack. In a stack, we had first in, last out data structure. Means that the first element that enter to the stack is the last element that could be out from the stack. But in queue, like normal queue that we have in our life, we have a FIFO data structure. Means that the first element is which enter to the queue is the first element that is a service and come out from the queue. So here we have some similar questions like what we had in a stack. In first question, we need to create a queue with 3 characters, B, M, and W. B is the first element, M second element, and W is the last element. Then we need to remove one character from the queue, print the front element of the queue, and finally print the number of elements in the queue. Again, students are coming and I need to check the class to give admission. So please be on time because maybe I don't check the class page and then I miss your admission. Okay. This is our queue. The first element is B and the last element is W. Last element always is what we need to service in the last as the last one, and the first element is what we need to service at the first step. So we need NQ to enter element, to add element to our queue. And when we need to use the queue or remove an element from our queue, we need DQ. What we service and what we remove from the queue is the first element in compare with a stack that we went to last element and pop the last element. In Q, we pop or we remove the first element, which is B. And the front node of the Q is M. Here, always we have the front pointer to the first element of the stack. The element that need to be removed is pointed by front. And the last element of the stack is pointed by ray, or we call it back pointer. So here is front of the stack. It's necessary to know here is front of the stack and here is back or ray of the stack. So when we remove one element from the stack, we remove it from the front queue. We remove it from the front of queue. And when we need to add some element to a stack, we need to add on array or back of the stack. The code is very simple. We use enqueue to enter characters to the stack. enqueub, enqueum, W, then we are creating our queue, and then we use show queue to represent all the elements of the queue. After that, when we want to remove or service one element from the queue, we use dequeue. When we use dequeue, the front element or the first element will be removed from the stack. The first element here is B. So we are removing B when we use dequeue here. Then when we show the queue again, we have only M and W. And when we want to just represent the last element of the stack, we use peak. Using peak, like a stack, we don't remove the element. Just we show the last element. Here in Q, the last element is the front element. So we use peak to show the front element. The front element is M. Why? Because B already is removed from the stack. So the M is the front element. And we use get size to see to get the size of the stack. Here we have 3 elements. So using get size, we will receive 3 in our output. Okay, in next question, we are going to implement queue. We need to implement constructor in is empty, is full, get size, in queue, dequeue, peak, and show queue by ourselves. We need to define these functions by ourselves. First, we need to know that we assume that our queue is as a circle, and we have a maximum size for our circle. In this question, they mentioned that we assume that we arrange array in a circle, means that our queue is as a circle, and the maximum size is 10. So we need to consider these two. for implementing these functions. Okay, the queue is like this. We have a front and array. Array is the back of the queue, and the front is front of our queue. We need to know one thing. Always array is pointed to a empty position at the end of the queue. So this position that array always is pointing to that is empty position. So when we want to add an element to this queue, we don't need to increase array at the first step and then insert an element. We need to insert an element and then increase array. Why? Because array always is pointing to the empty position at the end of the queue. Means that here we have our last element. Let me do something. Okay, you assume that here we have some element. Okay, our element inside of the queue is like this. Here we have 4 elements. Front is always pointing to the front element, and the array is always pointing to the last position at the end of queue. So when we want to add something to our queue, first we need to enter the element. We need to assign element for this one, and then increase the array. Why increase the array? Because we want to have the next position, the next input, the next empty position. So it's like this. But for front always is pointing to the first element of the queue, and when we want to remove an element from the queue, we at the first step we need to remove the element and then decrease the front to point to next element. So let's go to program, then we can discuss more. But you need to remember that array is always pointing to empty position and front always pointing to a a first element of the queue. We need to have the same output of the first question, but the difference between this program and the previous program is now we are implementing the related functions by ourselves. We define three variables: front, ray, and size. Size are keeping the number of elements inside of the queue. For example, here, what is the size of in this? What is the size of our queue? The size is 4. Why? Because we have 4 elements inside of the queue. Okay, is empty is a Boolean function, and if the queue is empty, the size should be 0. Means that we should not have any element inside of the queue. So the size will be 0. And if the stack is full, then we assign max for the size. Why? Because the maximum number of elements inside of the stack is equal to max. Here we have 10 for max, means that the maximum size of our queue or the size of our queue is 10. So when size is equal to 10, we find that we reach to the end of queue, means that we cannot add any element. So when the queue is full, we assign max for size variable. And get size simply return the size of queue. Here we have in queue. In queue we need to check whether the queue is full or no. Why? Because we using in queue we want to add an element to our queue. So if our queue is not full, then we can enter a new element. So using is full, we check. If is full, means that if size is equal to max, then we need to return queue is full. We need to represent queue is full. Else means that if it is not full, then we put A in queue ray and then increase ray. Why we have here, why this statement is the first one and this one is the second one? I already discussed about it. Here we have these two. When we want to add a variable, a value to our queue, we need to first assign a value to ray position and then increase ray. why we don't have ray plus plus and then we have q ray equal 1? Did you understand my question? Hello? Can you hear me? Okay. My question is why we have this statement as the first one and this one as the second one. Why is like this? Why we don't have, why first we don't have ray plus plus and then q ray equal a? Yes, correct. First, we need to enter the element. Why? Because the ray always is pointing to empty position. Do you remember the circle? If you remember the circle, you can see ray always is pointing to empty position. So first we need to assign a value to that position and then we need to increase ray. Again, I return here. First, we need to assign a value here and then we increase ray to point to the next empty position of Q. Okay, is it clear to everyone? And we need to also increase the size because when we in Q or insert one element inside of the Q, the size of Q will increase. So we need to increase the size as well. Now for DQ. For DQ, we need to use front. For entering element and inserting element to the queue, we need to use array. But for removing element from the queue or showing the last element of the queue or front element of the queue, we need to use front pointer. Okay. For DQ, we needed to check whether the queue is empty or no. If queue is not empty, then we put the front value to A. And then we increase the front. We increase the front. Why we use this for increasing the front. Why we don't simply write plus plus for front, and we use front, then divide to max, the remain of front divide to max. Why we need this one? Do you know? I will show you the code again. Now we want to know the answer for this question. See here, after we put the front element of the Q to A, or after we remove the front element of Q, we have this one. We divide front by max. For example, here max is 10. We divide front by 10, and then increase front. Why we have this one? Why we don't increase front simply and we use this one? Do you know the reason for this one? Okay. Any answer? Okay. Okay. See, we have the structure of array here is a circle. Okay. So if we just increase front, increase again and again using enqueue, then it will exceed 10. The front will exceed 10. Why? Because the structure is circle. So in first round, for example, we go to 10 and we remove some elements, and again we increase front, then we serve element, then we have an empty position, again increase, we enter another element to our queue. The queue is circle here. This queue is circle. So we remove this one, and for example, we increase one. Okay, sorry. And can you see the page, my screen? Can you see my screen as well? Okay, so let's continue. Okay, I was telling that because we have a circle for our array and we don't want to exceed 10 for front, we need to have this one. We need to have a front divided by max uh, and then assign this one as new value of front. So when we want to remove one element from the uh, queue, first we need to uh, put this element in a variable like a and then increase the front. But we cannot simply increase the front. Why? Because the array is a circle, and if we again and again increase it, uh, we will exceed from 10. So we need to divide it by max and then put the remain as new value for front. Then we decrease the size. Why? Because we already removed one element from the queue. So we decrease the size and we return a which is keeping the front element of queue. Okay, you wanted to see the previous code. Okay, did you see this one is for in queue? This one is for in queue. That we check whether it's full or no. If it is full, we represent queue is full. Else, we first enter a value to position of ray because ray always pointing to empty position, the last empty position of the queue. And then after we assign uh, value for the position of ray, we increase ray. For in queue, we need to increase size because we already add a new element. But for DQ, we need to decrease the size because we are removing one element from the queue. Okay, with peak, we are not going to remove element, just we are going to show the front element of the queue or the element that is ready to be serviced. So we use front pointer to show to return the front element of the queue. That's all. We don't increase size, we don't decrease size, we don't increase front. Why? Because just we are going to represent the front element. That's all. And for representing Q, we need to check whether the Q is empty or no. If the Q is empty, we represent Q is empty. If it is not empty, we need to use a loop uh, with the size of Q. For example, if we have four elements inside of our Q, we have four iteration for this loop. Again, we have this one because we are going to use front element, a front pointer. We represent the uh, front element of the Q, and we use divide by max because here the Q is in a circle, and we need to put the remain of uh, front plus I by divide by max as a new value of front plus I, because we don't want to exceed the 10 for this pointer. And the next question, for the next question, we need to simulate a queue of purchasing and buy phone. Okay. In this question, each element of our queue is a string. The first element is this one, customer one set. The second element of queue is this string, the second string. Customer two sets. So each element of this queue is a string. We need to record the purchase of customer. How? We have two conditions. Each customer can only have maximum three sets, so this number cannot exceed three, and the total number of phone which is available is 30. So the addition of these numbers, or the total of these numbers, the total number of sets that are purchased by customers should not exceed 30. It's very simple. The code is very simple. Here we have we have one loop. In the first loop, we check whether the remain item in our stock is less than three or no. If we have more than three, still we have more than three items in our stock, then we continue and we go to this loop. Otherwise, if we have less than three items inside of our stock, then we go to the next step. So what we are going inside of this loop, we are going to get num. Num is the number of sets that is ordered by customer. So the first element of uh, queue is, for example, customer one, and the number of the sets that he or she ordered, for example, if is two or three, then we have sets. And in next statement, we put temp as the first element of queue. So we enter this uh, value, which is a string, to our queue. And then we decrease the total by num. For example, the first customer ordered two sets. So we need to reduce 2 from the total. If total is 30, now the total will be 28 because the first customer ordered two sets of phone. Then in next iteration, we again check total is 28. Now total still is greater than 3. So we have the next iteration, customer 2, for example, order 2, another 2 or 3 uh, sets of phone. Then we have similar, we put this string for customer to our queue as the second element of queue, and then again we decrease the total. So we repeat this loop until we get less than three elements in our total. For example, we have only one element inside of our stock. Then we go to the next step. In next step, we check whether the total is 0 or no. If it is not 0, then we add the last element of our queue. The last element have the similar structure when first we have customer, then number of customer, and here we have total. Why? For example, total is 2 or 1 from here, so we put directly total here. And then we enter this to our queue. For this one, we don't check the number of sets that is requested by customer. Why? Because just we look at the stock. If, for example, one or two items are remain to the stock, we assign that to the last customer. And using show queue, we represent the queue. Okay, let's go to next one. Question 4 and question 5 are related. We need to check whether a word is palindrome or not. In question 4, we have more restrict situation to accept a word as palindrome. For example, here in question 4, we consider a space and uppercase sensitive case. We consider this. So for this one, for this sentence, was it a car or a cat? I thought this one is not palindrome. Why? Because here we have capital letter and here we have a small letter and here we have some space. So this one is not considered as palindrome. But this one, the first one is palindrome. Why? Because we can exactly uh, have the first part at the end of our word. So for question 4, to check whether a word is palindrome or no, we just need one stack and one queue. One queue to keep the original word and one stack to keep the inverse of our word. Okay, so in a stack we keep the inverse of the word, and in queue we keep the original word. Then we start to remove elements from the queue. In first step, we fill up queue and we fill up the stack with our word, and then we check whether the stack is empty or no. We continue to check. If the front element of queue is not equal to uh, last element of the stack, then we return false. And if the last element of the stack is equal to the front element of the queue, then we return true. We use dequeue and pop, means that each time we are going to remove the front element from the queue and the last element of the stack. So using this loop, we check all characters of a word, and if totally we read true, means that if uh, we don't have false, then show we have palindrome, like this output, like checking these words. But for question 5, we should remove sensitive. We should not be restrict. For example, here, was it a car or a cat I saw? This one we consider as a palindrome. So we need to do not consider to a space, and need to do not consider to upper and lowercase. So what we need to do, just we need to uh, check whether is digit or letter. If we reach to a letter or a digit, then we push it in the queue, in the stack. And if we reach to a letter or a digit, then we enter it into queue. So we don't enter any space inside of queue and inside of our stack. After that, we for entering the characters inside of our queue and inside of our push, we convert all of them to lowercase. So when we convert all of them to lowercase, then we don't have problem to make difference between lowercase and uppercase. Using these three statements, we solve the problem. And the remaining part of the program is same as question number 4. So the only difference between this question and the previous question is adding three statements. I will prepare screenshots of this tutorial and previous tutorial and upload in a Spectrum. Then you can see the questions easily. And the last question, we need to inverse, need to reverse one sentence. In step, we could reverse one sentence. At the same time, we could reverse the words of the sentence as well. But in Q, it's difficult. It's difficult. And now, using the stack, we do it very easy using two stacks. But in Q, we need to use three Qs, and only we can reverse the sentence. We cannot reverse the words of the sentence. So in this question, we need just to reverse the sentence. So we use three Q to Q as a temp to keep the word and make the sentence and reverse. So I put the screenshot of this answer in a spectrum. Then if you had any question, uh, just ask me through a spectrum. I will answer your. Okay, I give the class to demo.